Hello and welcome to Total Destruction Volume 1, Fracturing. In this first tutorial, you will learn everything you need to know to fracture your geometry in preparation for rigid body dynamic simulations, particle simulations, and even fluid dynamic simulations. Before we actually start fracturing our geometry, let's talk about some do's and don'ts to consider before creating destruction, especially rigid body dynamic simulations. Also, let's get acquainted with this minifigure geometry that will be included with the course. Before I show you the minifigure geometry, let me open another file that I have prepared beforehand called test geometry. The file will also be included with the course. So here I have a switch node, and to it I have connected 5 different geometries: a box, a sphere, a wall, an open box, and a somehow tangled sphere. So let me explain some things that you need to be careful or mindful of before you start creating fracturing. And especially if you're going to create rigid body dynamics, there's a few basic concepts that you need to check before you start working. The first thing I want to talk about is the concept of watertight geometry. I will select my switch node and change to geometry number 0, which is just the standard box. And below the null, I will connect a subdivide node. Notice how the box has been completely rounded as expected. But if we switch to geometry number 3, you will notice how one of the corners is not being rounded as the rest. The reason why this is happening is because we have an open corner here, and you can check that by pressing the S key, selecting this corner point, and then pressing T to transform it. So if I move this point upward, you will notice how here we have a few open edges. Whereas in the standard box, we have completely closed geometry or watertight geometry. So if I try to select this corner point and translate it, you will notice how this is one unique point, which makes a completely closed geometry. Watertight geometry is ideal for rigid body dynamic simulations, whereas open geometries can sometimes lead to some trouble while simulating, and especially when fracturing with Boolean-based techniques. Another thing that you have to be mindful of is crossing or intersecting geometry. If you take a look at this sphere, to which I added some extreme noise, you will notice how there's some faces that are shaded in a different way. This is very useful because it shows us where the faces are intersecting or where the faces are pointing backwards. This can also lead to some trouble when fracturing or when simulating with rigid body dynamics.